one, yeah, that's a good one.
Okay, this is section 112, number 31. And the question is 1 over f is equal to I don't have my glasses on.
15.
1 over s sub 0.
Yeah, plus 1 over s of I.
Thank you. Okay, and in this particular case for number 31, we want to solve for s sub I if we know f is equal to 15 centimeters. S sub I, and we know, okay, f is equal to 15 centimeters, and s sub 0 is equal to 20 centimeters. Okay, so you have a choice on this. You can solve for s sub I first, or since we actually know numeric values for this, it's usually easier if you put those in first and then solve for your missing variable. So I'm going to slide this up. So into our equation where there's an f, we're going to replace that with 15. So we get 1 over 15 is equal to, we know s sub 0 is 20, so we're going to get 1 over 20 plus 1 over s sub I. The advantage is we have a lot less algebra to deal with at this point, solving for the s sub I. So we're going to treat it just like that unknown variable, do your order of operations on each side, none in this particular case. Then your variable teams. We're going to have an issue because our variable's in the denominator, so we'll deal with that when we get there. So now we're going to get the number team on the same side, so we're going to subtract the 1/20th. Okay, so 1/15 minus 1/20 is?
I got 4/3, so 1 1/3.
Okay, 4/3, though we're going to leave it as the improper. It's just more convenient. I don't think that's true, though. Is it? How many?
1 over 60. That's where I went wrong with the problem, and I got the wrong answer when I did it. 1 over 60.
Okay, is equal to, or then is equal to 1 over s sub I. That sounds a little bit better. Okay. And here's how, and a lot of times when you're looking at them, it's very easy to type something into the calculator wrong. It happens to everybody. You know, you hit the button and it doesn't take, or you hit it and it takes twice. That part's okay. So always be looking at your numbers, and even if you don't know what the answer is, does the answer make sense? Thinking about this in terms of, you know, like a pizza, because I'm always starving. So I have only one slice of things cut really small, and I've taken away another really small slice. If we had landed at 4/3, if I had less than 1 and I took away less than 1, I can't land at more than 1. Okay, so just a little red flag to kind of help you when you're typing things in. Okay, so now I'm solving for s sub I. So you have two options here. There's a math way to do that, but don't forget about the common sense when it does show up. Twins on the teeter-totter. If 1 is proportionate to 1, then 60 is proportionate to s sub I, and you're finished. All right, those are both, the numerators are exactly the same, so the denominators would have to be exactly the same. So the answer is going to be 60. Or if you go, if it wasn't that convenient, you'd cross multiply exactly. So 1 times s sub I is equal to 1 times 60, and there you go anyway. Yep, so the answer is 60. Okay. We have time for one more. What do you want to do?
67 of 114
1.8.
of 114. They come up with an answer of 120, but I had 117. Did they round it up, or did I do something wrong?
On which one? 60.
67.
67.
It's 28 over 52.
Okay, actually, I'm going to put that one on hold for a minute because we had skipped part of the, we'd skipped this section, and I'll come back to that one later.
Okay, that's fine.
Okay? All right. Other ones that we need to do?
114.9.
Don't forget to remind me of that one tomorrow.
Okay.
114, number 9.
Yeah.
Okay. express each ratio as a fraction in simplest form. So your units are exactly the same. Okay, so always watch for that. We're gonna have one today where the units are way off a little bit. And all you wanna do is reduce that fraction. 28. We're looking at numbers 9. Okay, so it's 28 inches. Oh, I see, because the square was on the outside.
I reduced it down, I had 4, and I looked back up at 16.
16.
So I thought you just reduced them first and then you square them.
Fine.
That's fine.
Because they're exactly the same on the the exponents on the outside, you can reduce because these proportions are the same. This is the same thing as 28 over 7 quantity squared, because that exponent can be distributed to the top and the bottom. So in this case, which keeps the number smaller, if I don't have a calculator handy, that's a quicker way to go. 28 over 7 is 4, which is still being squared, and that's where you get the 16. Okay, here, you're going to have to square 28, get a huge number, square the 7 and get a 49, and then divide, and it'll still be a 16. A little bit less work to do to go that way. What is 28 squared?
784.
Divided by the 49,
Right.
which is still the same, 16.
Okay, can we do number 7?
On,
Same one. It's the same thing except for they got the parentheses.
okay, that one you're going to have to, there's a fraction in simplest form. Your units are different
Right.
in that case, so we're going to have to convert those. It doesn't make any difference to me if you go to meters or centimeters. You're looking at 1.75 meters. And it was 35 centimeters. Okay, so they have to be the same unit. There's a lot of different ways to make those conversions. Are you guys familiar with converting from centimeters to meters and back and forth? Yes, no, maybe so. Okay, here's the non-mathematical way to do that. They're proportions. The reason the metric system is so nice is it's just multiples of 10. So it's just like our number system, and it's so much easier to use than the inches and feet and yards. But, okay, there's 100 centimeters in 1 meter, exactly. So we're going to end up taking this times 100 to get our answer. The mathematical, or that's the math way to do it. Then there's the actual conversion, goes kilometers, hectometers, decameters, and decimeters, centimeters, and millimeters. And you notice I only put the front part on that, like kilo. I didn't put the actual meters because it's true for meters or liters or grams. It's the exact same conversion. And if we're going to convert from meters into centimeters, for example, because again, it doesn't make, if they don't specifically say, it doesn't matter which way you go. But if I want to get from meters, right, I would move my decimal point over to the centimeters. So I would end up moving at 1, 2 to the right. So I'm going to move this decimal point 1, 2 to the right. Same thing as multiplying by 100, but sometimes you forget, am I supposed to multiply or am I supposed to divide? If you start at that unit, if you move to the right, move your decimal to the right. If I was going to kilometers, I'd move to the left and I'd move 1, 2, 3. Okay? So I get 175 centimeters over 35 centimeters, and then divide that out.
It's the same thing as milli, micro, kilo.
Exactly, exactly. And we could have done the same problem, converting them both to meters. Then let's get this one finished. 175 over 35. You can do that by hand, take out your multiple of 5, then see if 7 goes into it if you're not sure what your value started with. But if you type in a fraction of 175 over 35 and just hit enter, it'll automatically reduce it for you. Okay, so survey says? 5. 5. It was a whole number anyway, so that's great. Okay, don't forget the units there because we had to convert those.
Top and bottom. It's unitless.
Oh, it's just a proportion?
Yeah, you have units top and bottom, they cancel out. There's no units to the answer.
Okay. But if we converted it, you don't want, okay,
There wouldn't be any units to the answer.
Okay.
Because they cancel each other out when you do 5.
okay. So your answer is 5. Next, we're going to move on to the next section. And that's going to be the section for the applications. Now, every one of these is a little bit different. Every one of these is a little bit different. So you're going to have to bring some outside knowledge into them occasionally. There will be small issues like area and perimeter of a shape, some information about triangles, but nothing that is outside the norm that you'd have to have a specific field to know. If you're ever in a situation where you just can't remember what's going on, feel free to ask. It's not a big deal, because I can tell you what the formula is. If you don't know what to do with it, it doesn't make any difference anyway, right? So we're just going to pick a few of the evens out of this section to kind of get you set up. This is actually 113. I wanted to make sure I had a full house for applications, so I waited until today because I'm assuming most people are gone for the weather. Yeah.
I have a quick question. So if that problem was on the test, what would the answer be? Would it be similar to square or not?
Just go with 5.
Do it 5? What if we put 5 centimeters in my
I won't take off for that. Okay, so next section is 113. So all of these homework problems, if you need them later, will be at the front of the section 113. Okay? And the set of built, we're going to do, oh, sorry, that's your number 3. We're going to start with number 8. Now, for the most part, they tried to pick homework problems that are actually tagged in with electronics if possible, but at least something that's, you know, more job specific. Some of the examples in here, they're all real life as close as they can possibly come. So we're going to look at some of them that are finance, so it might not apply to your specific job, but it would at least be a real scenario. Right? And they do a pretty good job with keeping them as real life as possible. So number 8 is the one we're going to start with. I'm only going to write it up partially on here since you've got your book for a reference for the whole thing. That you don't need to get it out though. Okay, we're going to deposit $6,800 in 2 accounts. And let's see. One account is interest is 8% and the other is 10.5%. Okay, make sure when you convert those, we're going to go back to the decimal. So 8% we'll write as 0.08. Now 10.5 would be like 10.5, right? So we'll rewrite this as a decimal. Exactly, 105. Good. Okay, so we have these two. And the total interest earned from both accounts at the end of the year is $669. Now, there's more than one way to do most of these problems. The one that we're going to do is useful for a lot of different scenarios, and it doesn't require a huge amount of algebra to get it done. We want to find the amount deposited in both. Eventually, we're going to work with matrices and systems of equations, and there's a completely different way to do this. This one's just a little more streamlined in a way we can handle it to begin with. This is going to look a little bit silly, but you've got one that you have to do a mixture problem with, I don't remember if it was copper and lead or something with acid. You have to do some sort of a percent mixture. This technique looks silly, but it works for every single mixture type of problem where you have one idea going on with 2 facts, another idea going on with 2 facts. So, okay, we're actually going to have these 2 containers. Containers is always going to be filled with 2 items, whether that's money in pounds if they're selling peanuts, if that's a percent, and a volume if you're mixing the chemicals together. In this case, it's an amount of money and an interest rate. Okay, doesn't matter who goes on top, who goes on the bottom at all. I'll just put percent on top. Each one of these containers, this is my first one, here's my second one, and this is the total. Okay, so we're just going to start filling in each one of these. Most of the time, your total will be pre-mixed for you, but it could just as easily have 2 items also. Okay, so our interest rate for the first one is 8%. Our interest rate for the second one is 10.5%. We don't have a total interest rate because what we're getting is our total interest back. So the total is pre-done at $669. Okay, but now we have to get this second line of how are we going to split up this money. We've got $6,800 to spread out. So I don't know if that was 6,800 or 1,580 or whatever, 5,800. I don't have any idea how that money was split up. So we're going to say he put a certain amount into one account and he put the balance in the other one. So this element right here is 6,800 minus the amount I put in the first one. Okay, the setup is the hardest part of these. Okay, each one they always have two items. Again, ours is percent and money. So we fill in the percents across. This one was pre-totaled, so we don't have one. And then for our money, usually, if this is how they're going, is with some sort of a total volume or a total amount of money. One of them's X and the other one's going to be number minus X. It's not a guarantee, but it's a good place to start. Okay. Now, the idea of these little containers is that you're going to actually mix up or multiply each one of these containers. So we're going to multiply 0.08 times X and 0.105. Now we've got two things to multiply here, so I'm going to use parentheses around that. 6,800 minus X, and that last one's pre-done at 669. Okay, so that's how you get it out of the containers. It's a multiply. First one multiplied, second one multiplied equals the last one multiplied. Yes?
Could you have a 6,800 minus X?
Totally could have it on the first one. Let's say all I cared about was how much was in the 8% account, then I'd leave it like this. If all I cared about was how much was in the 10.5%, then absolutely I'd want to switch those because it'd just be quicker in the end. Okay. All right, so now we just need to clean this up. So we're going to take care of the order of operations on each side. So 0.08x plus, now we need 0.105 times 6,800.
714.
Thank you. 0.105 times x equals 669. Okay, so the multiply is done. Now we need to add like terms. So we can add together the 0.08 and the negative 0.105. Got it. Okay, so all we did was combine like terms. So 8% minus 10% would be approximately negative 2%. So make sure that the answers kind of make sense when you're going through there. So the X team is already combined. So we're going to move the numbers over to the right. So minus the 714 from both sides. Now your numbers in this case are going to end up negative. Don't let that bother you, even though it's money and we're making an investment. It'll work itself out in the end. So I get negative 0.025x. These 700s cancel. Equals negative 45. Then divide both sides by the coefficient. So we're going to divide out the negative 0.025. That's where it goes back to the positive amount for the money, so it works itself out in the end. How many? 50. Oh. It does if it's wrong. Oh, 45. It's okay, always check because it could be wrong. Okay, so we need 45 divided by 0.025. 1,800. Okay, then always go back to what is it that the question is actually looking for. Did they want to know just the 8% or just the 10.5%, or did they want to know both of them? And what does X mean to you? Because if somebody's asking you how to split up money and you walk up to them and talk about X, they're going to think you're crazy. What are you talking about? So for us, X, back up here, X was the amount that we had at 8%. So to figure out how much we had at 10.5%, same as we did with the container, if I put 1,800 in here, then I would have to subtract 1,800 from my total pile of cash. Right, and you end up with 5,000. Oops, not 5%.
So that would work for if you were doing a mixture, those mixture problems.
Any of the mixtures, like if it's a percent and milliliters, if it's, you know, if you're working at the store and you're trying to get a price point and you've got something expensive, you want to mix with something not quite so expensive to bring the price down or up, right? Anything that you're mixing two ideas together, that'll work. I don't remember what yours was. It's either an acid or a, like copper lead. Tin and lead. Tin and lead. It'll completely work for that idea too. Okay? So that's one of the techniques. There is a different algebra ways to set that up. I just think this one's kind of visual. You can actually think of them as separate piles or separate containers that way. Okay? Then the other one that we're going to do kind of matches your 23. We're going to do 24. Same section. Okay. On 24, it's talking about different angles. It says one of three angles is 5 more than the smallest.
113 or 114?
Oh, so 113. One angle is 5 degrees more than the smallest. And then it gives you another, we're just making a list of the facts. The third angle is 3 times the middle. And then it tells us something about the sum of them. If it would have actually been in a triangle, how many degrees are in a triangle? Oh, not 180. Exactly. No, I know what you meant. Exactly. This one, it must not be in a triangle, though, because it's got the sum is 120. That was funny. I liked it.
I don't think so.
We want to find each angle.
So does everybody else.
Okay, so we can call the three angles whatever you want. X and Y and Z, or A and B and C. Just give them first and second and third, whatever trips your trigger. Whoa. Okay, so I'm just going to call them A and B and C. Okay, so they're talking about the smallest angle and then a middle-sized angle. So let's just start with the first sentence. One angle is 5 degrees more than the smallest. So somebody has to be the smallest. Totally don't care who, but I'm just going to make it A since that's my first one listed. Okay, so this is going to be, I'm just going to go back to the X. You can use whatever letter you want, but I'm going to use X and we're going to call that the smallest. Okay, then another angle out there is 5 degrees more than that. I have no idea how big this is, but if it's 10, the next one's 15. If it's 20, the next one's 25. So more than means to add. So this one would be X. I'm just working my way down the list. So the next one is X plus 5.
Why 5?
Because it's 5 degrees more. It's all right. Okay. Now, the third angle, so angle C, is 3 times the middle-sized angle. Well, we already said this one is small, and this is one I'm looking for. Yeah, so it's got to be the X plus 5. If it's 3 times that amount, it's 3 times the entire size. So you're going to have to use parentheses around that. Because it's 3 times the middle-sized angle, which is the X plus 5. Okay? Now, we know that the sum, and again, sum means to add. So if we add up these 3 angles, we're going to land at 120 degrees. So we're going to make an algebra statement out of this that says X. Now I'm putting parentheses here only to show you the, actually that'll make it too confusing. Let's just go with the values. We're going to add up X and X plus 5 and 3 times X plus 5. And that sum of the first and second and the third is 120 degrees. Okay? So again, the setup is always the hardest part. Then we go right back to the idea of solving equations. Order of operations on each side, combine like terms, right? It's part of that order of operations. Separate your teams and divide out the coefficient. So combining or like terms, we'll get there. Let's do that distributive property. So we have x and x plus 5 plus 3x plus 15. Don't forget to go all the way through. Put all of your x's together. There's 1, 2, and 3 is 5. So we have 5x plus 20. Okay, so
Where's that go with that music?
I don't hear it. No, but glad you're liking it.
No.
Oh, you're not liking it? Oh.
It drives me nuts.
Oh, I'm sorry. You'll have to change the station. Okay, so next we're going to separate. We're going to separate the terms. So we have a 5x on this side, and we're going to exactly subtract 20. So we get 5x equals 100. Then always divide out the coefficient. So divide out your 5. X is 20. We can't just stop there, x is 20, because somebody was asking us about angle sizes. So if we walk up to them and say x is 20, we'd be like, I didn't ask anything about x. So we take that information back to the original list where we knew a was x. I'm going to put it down here so you can see it better. A is x, b was x plus 5, and c was 3 times the quantity, x plus 5. So our smallest x is 20, 25, and 75. Good, 3 times that size. Double check yourself, make sure that that actually adds up to 120 degrees, which it does, so yay. There you go. You don't need to leave the labels on them of A and B and C. You can if you want. There's nothing wrong with that, but nobody told us anything about ABC to begin with. That was just something we did for a convenience factor. Okay? These little steps like this are not a requirement to get the correct solution, but they sure help get the setup done and prevent little silly mistakes as you're going through there. Okay? Okay. That was fun. All right. Now, the one we were talking about earlier that had a unit change that was involved with it. All right. We're going to take a look at one of those. This one is number 10. Okay, so they want to fence the yard. This is number 10.
Still on 132?
Yep. Okay. But it's not just go ahead and put up a fence. She's got some criteria that go along with that. She wants to use the entire back of the house, 70 feet long, is one side of the yard. So one side is 70 feet. And she has 50 yards of fencing. And they want to find the largest yard that they can, or largest amount of space that they can enclose. Okay, so we have some issues with this. First of all, it's coming in with feet and yards. Doesn't make any difference to me which direction you go, but it would be more convenient to go down to feet instead of up to the yards, because then I've got to deal with fractional amounts and it's just a lot more work. And most people talk about it in terms of linear measurement in terms of the feet anyway. So we're going to multiply that out. Yes.
Is this 70 feet the side of the house?
Yes.
Okay.
Exactly. Exactly. So we're going to convert this 50 yards into 150 feet of fencing. All right. Now, you don't have, sometimes drawing a sketch, just a little small diagram of what you're doing makes a world of difference. So I've got the house, right? And we're going to say that that's 70 feet long, and there's my house. Or like a boat or something. But anyway, so there's the 70 feet. Sad. So we draw the fence line in. We don't need to put fence right against the house. Right? So the amount that we're going to need, we know that this side's going to be 70 because it's a rectangular space that she wants to enclose. And these are the ends that we're trying to figure out. How wide out do we have to come? All right. Now, normally, the equation for the perimeter, which is what you need for your fencing, perimeter is equal to 2 times the length plus 2 times the width. But in this case, we already know that we've used up one of those lengths. So when we put our fencing out, we actually are only going to use one set of 70 because I don't need to use up the other 70. Does that make sense? Okay. And then I still do have the 2 widths, or 2x, whatever you want to use for that. And then I know that the total perimeter is the amount of fencing that I have, which is 150 feet. Right? So normally we would use 2 times that, and we'd have 140 here, but we don't need to fence the house side. So it's just 70 plus 2 widths to use up the 150. Then in order of operations, that's already been done. It's just a number and a letter on the right and just a number on the left. So go ahead and separate teams. The letter's already together at 2W, so we'll subtract the 70. Okay. So we're going to get 80 equals 2W. Divide out the coefficient. Right, so even though I'd never ask you on a test, what's the definition of coefficient, you have to be able to know what I'm talking about when I say words like that. So W is equal to 40. Okay. So I think what they're actually asked for in the question, the final one, was find the dimensions of the yard, largest yard that could be closed. Yep. So we've got a width of 40 and a length of 70. So a 40 by 70, the biggest yard that she can make. 40 goes here, 40, 40. And this one's also 40. So if you count that up, 40, 80, 150. So we used up all of the fencing that we had because, again, we didn't need to use this side of the house. Okay, so you see, those were 3 questions that we did. Every one of them was unique. Right? We did a mixture problem, which you're going to have. We did a normal is a crazy word, but something that is from your everyday life, like perimeter and area of not strange shapes. It's not going to be like of a pyramid or anything.
Now, if we have these problems on a test and we don't really use a formula, that one there.
As long as you show your work, yeah. As long as you show your work, I'll do that.
150 minus 70.
Pay me 2 and divided by 2. Pay me 2.
I just didn't write all that up. Yeah.
Get the job done. That's how you would translate it back into algebra, but we did the exact same thing. You just didn't have a W tagged onto it. Totally fine. Okay? In any of those cases, get the job done. But show your work anyway, even though that was all you did. Don't do it directly on your calculator and just give you the answer. Because let's say you just had one of those days and instead of 40, it ended up 30. Right? Just as, totally didn't make any sense. You wouldn't have done it any other day, but you did it that day. I have nothing to support where 30 came from, so I assume that you just guessed and wrote something down. So that's totally fine. Just minus 70 divided by 2. Good.
So what if we do test and get the right answer?
That's your lucky day.
Okay. So that would so like you're not gonna dock us for not showing work, is what I'm
Not yet. No. No.
Bases are gonna dock.
No. Not at all. Any other questions on these? Okay. So that section 115. We're going to worry about that one later. Variation. We need to get in and get this test. The piece that we need, we'll talk about tomorrow. The test, though, I wanted to talk about that schedule. Today is Wednesday. Okay, and for the most part, we finished this section that we're gonna have as far as testing is concerned. We'll take that, we need the variation later. I'm just gonna give you enough that you need to get through that problem. And then, but that section will need a later time, so we're gonna do, Wednesday is finished that last section, 113, and then Thursday is gonna be a review. Friday, we're gonna start on chapter 2. We have too many people that aren't here on Fridays, and I'm not gonna do that many makeup tests, it's not happening. So our test is gonna be on Monday. Okay, everything that you have for homework is due on Monday when you walk in the door. Okay, if it's in a notebook, in a spiral notebook, and you've decided to keep it all together, that's great, totally don't care. Just make a stack of notebooks and a stack of loose leaf paper, and if you brought me a notebook, make sure you wait until it's graded, because I am not gonna carry them. Okay, so take it with you when you leave. But anyway, so the deadline, ultimate deadline for the homework is Monday. That gives you one more day in case you need to catch me in my office or anything like that.
So like, how's the homework graded, like,
Oh, yeah, like I guess.
because you can't really be wrong when you look at the answer in the back of the book.
Right.
So if you do it, do you get 100